subsets proper subsets Powerset superset and as well as universal set. So, whereas in this topic we are going to discuss about the subset, the proper subsets, power set, superset and as well as the universal set. So, here before going to know about this, so first of all we will discuss about the subset. So, here if we assume capital A and capital B as two sets, and in case if the elements of A are also the elements of set B, then set A will be called as the subset of set B. So, here first of all let us write the definition of the subset. Here if A comma B be any two sets, then set A is called the subset of set B if every element of set A is also a member of set B. So, here subset mean when we assume or when we consider A and B as two sets, each and every element of set A must present in set B, then only set A will be the subset of the set B. For instance, let us consider one example. Let set A elements are of 1, 2, 3. Similarly, I am going to consider one more set, that is B, whose elements are of 0, 5, 3, 1, 8 and 2. So, here when we observe the elements of set A, the set A elements are of 1, 2, 3, 1, 2, 3 are the elements of set A, and these elements 1, 2, 3 are also the elements of set B. Set B elements are of 0, 5, 3, 1, 8 and 2. So, here 1, 2, 3 are the elements of set A are also the elements of set B, because so here these elements 1, 2, 3 are also present in set B, 1, 2 and as well as 3. So, here we can write, therefore, set A is the subset of set B. So, generally the notation of the subset is denoted by the symbol called. So, here we can write as we can denote by this symbol as a subset. So, here in this case say set A is the subset of set B, therefore, we can write as here, hence set A is subset of set B. So, here this is the notation, symbolic notation, therefore, symbolic notation of subset is this symbol, or in other words, since A is subset of B, so A is contained in B. So, here B contains A reversely. So, here B set B is containing the elements of set A, therefore this set B will be called as the superset. So here each and every element of set A are also the elements of set B, that is A is contained in B, or in other words B contains A, therefore set B will be called as the superset of A. So here if A is a subset of B, then we can write it as A is contained. So each and every element of A is also present in set B, that is A is contained in B, or in other words set A elements are contained in set B, or we may say that set B contains set A. So elements of set B contains the elements of set A. So here hence set B is the superset of set A. So here symbolic notation now. So here symbolic notation of superset is, so here the symbolic notation of a subset is this, then the symbolic notation of a superset will be in a reverse manner. So here hence we can write it as, since set B is the superset of set A, we can write set B as B is the superset. So superset is denoted by the symbol, therefore it can be written as superset of set A. So here it can be read as B is the superset of set A, or set B is the superset of set A. That means, so here set B contains the elements, all the elements of set A. B contains A. Then now for instance sake, for example, I am going to consider set A whose elements are of A comma B comma C. So small a comma small b comma small c are the three elements of set A. Then now let us write all these subsets of this set A. So here set A is of A comma B comma C, then now number of elements. So number of elements present in the set A. So in set A equals 2. So here we can count it a number, that is, I mean, there are 3 elements, therefore the number of elements present in set A are of 3. Then now the subsets are of, one is an empty set, or in other words it can be written as 5. So here the condition is 5, an empty set will be the subset of every set. So here empty set is a subset of every set. Then now the remaining, I mean, subsets are of a set consisting only one element, that is A. So here this is also the subset, because A is present, set A consisting A, so A is present in set A, that is A comma B comma C. Therefore set A, set consisting A is also the subset of set A, given set A. Then now one more subset is of set B. So here set B, set consisting element B is also the subset of set A, because this set consisting B is also present in set A. So therefore, so this is also the subset of A. Set consisting C. So here element C is also present in set A, therefore set consisting C is also the subset of A. So now by taking 2 at a time, so here A comma B now. So here A comma B. So here the set consisting 2 elements, that is A comma B, are also present in set A, that is A comma B. So here set consisting A comma B is also the subset of A. Then now set consisting now B and C. So here this set is consisting 2 elements, that is BC. These BC are also present in the set A elements, that is BC. Therefore set consisting BC is also the subset of A. So here AB, BC and CA. So here let us take CA. So here this set is consisting two elements, that is C and A. These elements are also present in set A. So here therefore CA is also, set consisting CA is also the subset of A. Then now completely set A. So here set A is the subset of A, because a set, every set is a subset to itself. Therefore we can write as either A or set consisting A comma B comma C. So these elements set consisting A, B, C are also present in set A, that is A comma B comma C. Therefore either A comma B comma C set is a subset of A or A is a subset of A. From this it is clear that, so here phi, an empty set is a subset of every set, or a set, every set is a subset of every set. So in this manner we got. So here 5 has one set, 2, 3, 4, 5, 6, 7 and 8. There are of 8 subsets of this set A consisting 3 elements. So here from this we can write a note that an empty set is a subset of every set. We can write it as note number 1, and the note number 2 is of note number 2 is of every set is a subset of itself. So we can write here one example also. So here empty set is denoted by phi. If you consider any set as A, then now phi is a subset of set A. A is any set, whereas we can write it as, so here A as any set. So here if we consider A as any set, then now every set, let us consider it as A, is a subset to itself. So itself is again A itself. So here A is subset to A itself. The reason is, so here A is any set. Whereas here as per the previous, so here set A is consisting the elements A comma B comma C, the number of elements are of. So here number of elements as per the previous one. So here number of elements in set A is equals to, there are of 3. So here number of sets subsets. So here number of subsets. So here as per the previous example. So here number of subsets are of 1, 2, 3, 4, 5, 6, 7 and 8. There are of 8 sets which we got, I say here. Therefore 8 sets. So here we can write it as, if there are, if a set consists n elements, then the number of sets will be given by means of 2 to the power of n formula. So here if a set contains n elements, then number of subsets is given by the formula, that is 2 to the power of n. So here let us clarify as per the previous problem. So here number of elements, so here number of elements are denoted by means of n, then now number of subsets. So here number of subsets equals to, so here n is equals to 3. So when n is equals to 3, then number of subsets, the formula is of 2 to the power of n, then that is equals to 2 to the power of n value is of. So here n value is of 3. So here n must be represented by means of, replaced by means of 3, then that is equals to 2 must be repeatedly multiplied thrice, 2 into 2 into 2, 2 to 4 and 4 to is of 8. So in this manner I got, so number of subsets as 8 in this regard. So here when number of elements are of 3, then now number of subsets will be of 8. So here as per the formula, that is 2 to the power of n, so we got it as 8. So hence, so here number of subsets is given by means of the formula, that is 2 to the power of n. Then now regarding the proper subsets, so here regarding the proper subsets,